Hello everyone and welcome back to another video. So today we're going to be solving the LeetCode question, maximum erasure value. So in this question we're going to be given an array of positive integers called nums, and we want to erase a sub-array containing unique elements, and the score that you get by erasing the sub-array is equal to the sum of its elements. So we want to return the maximum score you can get by erasing exactly one sub-array. So an array B is called to be a sub-array of A if it forms a contiguous subsequence, so it has to be continuous. That is, if it is equal to, okay, so this condition over here. Okay, so in simple words, so let's say we're given this array of 4, 2, 4, 5, 6. A sub-array could be something like just the number 2, or we could have something like 2, 4, 5, or we could have 2, 4, 5, 6, or 4, 2, 4, right? So anything which is continuous is going to be considered as a sub-array. But there's an additional condition over here that it must only contain unique elements. So for example, 4, 2 would be a valid subarray, but 4, 2, 4 in this case would not be a valid subarray. So basically this question, all that it's asking us to do is we want to find a subarray with unique elements, and whatever subarray we find has to have the largest sum. So let's take a quick example at this, the first one over here. So one possible subarray is just the number 4 and 2. So that will give us a sum of 6. So basically we want to look for other subarrays which could possibly have a bigger sum. So let's look at another example. So we have 2, 4, and 5. So that would actually give us a sum of 11, right? So that is greater than the sum we had before, but there could still possibly be a bigger sum. So using that method, we just keep checking for the largest subarray. And in this case, it would be 2, 4, 5, 6. And 2, 4, 5, 6 would give us a sum of 17. And that's the largest sum that we can get. And that's what we end up outputting. We end up outputting the value 17. And the optimal subarray, like I showed you, is 2, 4, 5, and 6. So first, let's look at a brute force approach of solving this. And then we can see how we can solve it in a lot better and more efficient manner. Alright, so I'll just go over the brute force solution quickly, but let's not spend too much time over it. So essentially, we're going to have 2 for loops. And each time, we're basically going to look through each and every single possible combination, get its sum, and we're going to store its sum somewhere. And each time, we keep updating the sum value until we get the biggest value. And at that point, we're just going to return that. Okay, so what I mean by that is, in the beginning, we're going to start off with just the value 5. Then we're going to extend this. Our subarray is now going to be 5, 2. Then it's going to be 5, 2, and 1, right? So we're going to keep extending the subarray, and each time, each iteration, we're changing the starting point. But right now, we're still in this first iteration, right? And then we extend it again, and now we're over here. But now the problem once we come over here is that we have a 2, and we have 2 2s, and basically it's not a unique subarray anymore. So that's where the problem comes, and that means that we go, this is not a valid subarray, so we're going to stop, right? So at this point, what happens is we just account for everything we had until the values 5, 2, and 1. And this has a sum of 8, right? We're just going to remember the sum, store it somewhere. And each time we come across a larger value, we would update it. So now that we're done with this subarray, because we had this 2 here and it doesn't make it unique anymore, we go on to the next starting point, which is 2. So, and we do the same thing. So first we just have the value 2. Then we have 2, 1, and each time we're going to compare the sum with the current sum that we have and take the maximum. So right now we have a sum of 3, and then again we have 2 over here, which is incorrect in the sense that we don't have, it's not unique anymore. So we just keep moving on. Then we go to 1, then 1, 2, 5, so on and so forth, right? So each time we keep doing this until we reach the ending, and at that point we would have gotten the maximum sum in this place. Right? So let's just see what this looks like in code, and it should be a lot easier to understand. Okay, so this is what the brute force approach looks like. So over here we have our result, and we started off with a value of 0. And now we're going to have our first for loop, where we're going to do for I1 in range length of nums. And this is basically going to be each of the starting points. So we're going to consider each element as a possible starting point. Then we're going to have a set over here, which keeps track of the numbers that we currently have. And this way we only get the unique numbers. And then we're going to have a temporary value of 0. And this is the sum that the current or the temporary sum that we have for this specific iteration. Okay, so this for loop gives us the starting point. Then we have the second for loop here, which tells us where this array ends. So in the beginning, we just have the value of I1, right? Then we have I1 plus 1, I1 plus 2, and so on and so forth. So each time what we're going to do is we're going to go in this for loop, and it starts off at I1 and goes all the way up to the ending. So if at any point nums I2 is not in unique, what that means is the current number we're on has not been seen yet. So in that case, that means we can consider it. So what we're going to do is we're going to add its value to our temporary running sum, and we're also going to add this value to our unique number set. So the next time we come across this, so if this is not the case, we're just going to break out of this, okay? And then finally, so these are the two main conditions, and we'll just go over this later. Let's just ignore it for now. And then after this, outside of this for loop, we're going to check if whatever value, the running sum that we had, is greater than the current result we're holding, right? So in the very first iteration is temp greater than 0? If that's the case, our result is now going to hold the value of temp. And each time what's going to happen by doing this is where result is only going to have the largest value. And at the ending, we return result. Okay, so now let's just go over this small condition over here. So it's pretty simple. So essentially what it's doing is, so basically over here, so what happens is when the starting point becomes 2, okay? What we would do is we would first go to 2, then we would go to 4, then we would go to 5, and then we would go to 6, okay? So essentially what happened is we went all the way to the ending. From a certain point, we went all the way to the ending. And that directly means that anything that, any other sub-array that comes after this is always going to be equal to or less than this. Now the basic intuition is that right now we have 2, 4, 5, 6, right? So the next starting point will be 4. We would have 4, 5, 6, then 5 and 6, and then 6. So no matter what, it is never going to be greater than the sum of 2, 4, 5, 6. So if we end up going all the way to the ending, what I did is I put a if condition. If I2 is equal to the last index, then in that case, we're directly going to return either the maximum between our result or the temporary value that we have. So now this code over here does work, but as you can see over here, the length of nums could be all the way up to 10 to the power of 5. So that's really large, and in those conditions, we would get a time exceeded error. So now let's look at a better solution. And essentially over here, we're having 2 for loops, right? But we want to kind of just make this down into one step. And to do that, we're going to use a 2-pointer method. So let's see what that looks like. All right, so in our 2-pointer method, the basic intuition is that we're going to start off with 2 pointers. Let's just call it I and J, okay? And the basic purpose of I is that I is going to represent the starting index from where our sub-array starts, and J is going to represent the ending index of our sub-array. So essentially in the beginning, our sub-array is just going to be 0, 0, in the sense that it would just include the number 5 in this case. So each time J is going to be moving, okay? So first J would be here, then here. So each time it moves up one index, right? So the only other thing that we're going to change manually is the starting position. And we're only going to change that when we reach some sort of condition. So essentially it's a window which keeps getting bigger and bigger. But if at any point there's some sort of problem, so for example, if we go to 5, 2, 1, 2, the problem is the fact that we do not have a unique sub-array. So in that case, we would move the I until we get a unique sub-array. So currently I is over here. Then if we move I over here, we currently have 2, 1, 2, which is still not unique. So we're going to move I again. And now we're just going to have 1 and 2, which is unique. So now we keep moving J. So J would be 5, and then 2. And then again, we have a problem over here. So then we move I again and keep repeating that. And while we're doing this, each time we're going to get the sum of the current sub-array that we're on and update that. So if at any point, so result is going to be what we're actually going to end up outputting at the ending. And each time result is just going to hold the maximum value, okay? So we're going to have 2 sums. Let's just also initialize that. So we're going to have a result, which is going to be kind of like the thing we end up outputting. It's going to be the maximum sum. And then we're going to have a current running sum for each of the values. So for each of the sub-arrays as we're iterating through it. And finally, we're going to have one last thing, which is going to be the set that we had earlier. And let's just call it unique. And this is going to be all of the values that we have currently come across. Okay, perfect. Okay, now let's see how this all works with each other. Okay, so let's start off. I, like I said, is going to start off with a value of 0. And j keeps iterating. So in the beginning, 0, 1, 2, 3, and so on until the ending. Okay, so let's see what the first iteration looks like. So at the first iteration, we're currently over here with a value of 5. And what we're doing is we're checking if this value is inside of our unique set. And obviously, since it's the first value, it is not there. So then that means that we are going to account for this value. And the way we do that is the first thing we want to do is we want to add this to our unique set. And so we add it. So currently unique has the number 5. Perfect. And then we need to account for this value. And the way we account for this value is by adding it to our current sum. So just to make it more clear, result is going to be 0, current is going to be 0 at the beginning. So we're going to do 0 plus 5, and that's just going to be 5. So our current sum is 5. Now we need to do one more thing. We need to update result accordingly. So the way we update result is we take the maximum between the current result and the current sum that we have, which is 5 and 0. And obviously the bigger value is 5, so result is now going to be 5. Perfect, okay, so let's just keep moving on. So now what's going to happen is j is going to move on to 2. But remember, I is still at 0. So the sub-array is essentially 5 and 2, okay? So it's a window that keeps getting bigger. So let's now include the 2 in the sub-array. And the way we do that is by adding 2 over here. 5 plus 2 is 7. We also need to add 2 to unique. And now we check our result. So it's either 5 or 7. We want the bigger one. So result is now going to be 7. Perfect. So let me just go through this a little bit faster. So now we have 1 over here. 1 is not in unique. So we add 1 to unique. Then we add 1 to current. And result also gets updated. Okay. So this is where things change. So now we have the number 2. And the number 2 is already accounted for. Like we can see that 2 is in unique. So now what exactly is our next step? So now we're actually going to go inside of a while loop where we're going to stay in this while loop until 2 is in unique. So essentially we want to get rid of the other 2 which is inside of the subarray. And the way we do that is by moving I. So first I is at 0. So now we're going to move I to the next index. But before we do that, so currently I is here, we need to make sure that we're not accounting for the 5 anymore. So since we're not accounting for the 5, we're going to do 8 minus 5. Okay, so 8 minus 5 is going to be 3. That's our new current sum, since our subarray does not include the number 5. And another thing that we need to do is, since 5 is not part of our subarray, we also need to remove it. So now we're going to remove 5 from our unique list, set. Okay, so now the next thing is we iterate I by 1. So now I is going to be equal to 1, and we move it to the first index. So I is currently at the first index, and now we have the value 2. So in this case, before we actually go over here and make any changes, nums j is still inside of unique, and nums j is nothing else but the number 2. So we still go inside of this while loop. Now we do the same steps. Basically, we don't want to account for the value 2 anymore. So we do 3 minus 2, and now our current sum becomes 1. Okay, so our current sum is 1. And now the other thing is this 2 is not part of unique anymore. So we get rid of it over here. And now we need to, and now we iterate I. So I is going to be I plus 1, which is 2. And now we go on to the second index. So basically, I is now at the second index, and our window currently consists of the values of 1 and 2. And as you can see, we do not have the second I anymore. So now we continue with our steps, which is the same thing. We account for this 2, since we didn't do that yet, and we do it the same way. We add 2 over here, so 1 plus 2 is 3, and now we add this 2 to the unique list. So 2 is now in the unique list, and now we check if result has to be 8 or 3, and the result is going to stay as it is, since 8 is larger, okay? So hopefully you understand how this works, and I'll try to go through the next few steps a lot more quicker since there's quite a few numbers here. Okay, perfect. So we have 1 and 2 in this case. So J now moves on. We have 5. So this becomes 8. Unique includes 5 over here. And yeah, perfect. Okay, so now we have the number 2. And we have the same problem, which is we have 2 2s. Since the 2 is in unique, so we do the same steps. First, we move I. And actually, before doing that, we need to account for the 1 getting removed. We do that by subtracting 1 over here. We remove 1 from unique. And we need to, yeah, that's it. Okay, and now we iterate I by 1. So I is now going to be at the 3rd index. So it's going to be over here. And at the 3rd index, we have a value of 2. So we do the same steps again, since the 2 is still in unique, right? So we subtract current by 2, making it 5. We remove the 2 from unique. And then over here, the I value gets incremented by 1. So I now becomes 4. Okay. So I is at the 4th index, and our current subarray consists of the values 5 and 2. And we got rid of the other 2 since it's not in unique. So we do the same steps. Now we're accounting for this 2 over here. We do that by adding it with the current value. So 5 plus 2 is 7. Then the unique, we add that to unique, which is 2 over here. And that's it, right? And result stays as 8 because 8 is greater than 7. Perfect. Okay, so let's just move J again. So now we have 5, 2, 1. So that's a value of 8. 7 plus 1. Okay, same thing. So 8, we need to add the 1 to unique, and that's about it. And then we do the same steps again. So we come across another 2. So we need to account for the extra 2. So we do 8 minus 8 minus 5, giving us a value of 3. We remove the 5, increment the I by 1. So now I is going to be right over here at the 5th index. Now we account for the 2 since we don't want it either, since this 2 is still in unique. And then over here, we get rid of the 2 over here. And yeah, so that's it. So now I gets incremented to the 6th index. And so 0, 1, 2, 3, 4, 5, 6. We have 1 and 2. So now we need to account for this 2. The way we do that again is by adding that 2. So we add that 2 to current, making 3, add it to the unique set. And yeah, that's it. So 8 is greater than 3, so 8 stays as the result. And finally, we move the last thing, so J now becomes the very ending. And at this point, we account for the 5, so it will be 3 plus 5, giving us a current value of, 8. So we have 8, we add 5 to unique, and that's about it. So J has got all the way to the ending, and that means that we're done. And by the ending of this, result would have the largest value. And if you just look through this, we found the largest value quite a few times, 2 times to be specific. Okay, 3 times actually, never mind. So we found a value of 8 at this subarray of 5, 2, 1. We also found the value 8 at the subarray 1, 2, and 5. And we also found it over here at 1, 2, and 5. So essentially, this method guarantees that you're going to get the largest value, or a sum. And the way it works is pretty simple too. J keeps moving, the ending keeps moving, and the only thing we're changing is if any condition is met. In this case, if we have if we do not have a unique subarray, we're going to move the starting pointer until we get a unique subarray. That's exactly what we're doing. So now let's see what this looks like in code. Alright, so we're going to start out by defining our variables. So first we have our result at 0. We're going to have a current sum at 0 as well. And then we're going to have our unique set, which keeps track of the numbers that are currently in our array. And now we're going to have our 2 pointers, right? So we have the pointer I, and I starts off at 0. And J is going to be the ending pointer, except J is going to be inside of a for loop. For J in range length of nums, okay? So now, so this J over here gets us the ending indices each time. So now the first thing we want to do is, let's say we do not have a unique value. So in that case, we're going to go to our unique set over here. And to that, we're going to add the current number we're on. So the way we do that is we go to nums, and we're going to be adding the number in index J. Perfect. Okay. And the other thing is we want to account for this number. We do that by adding it to our current sum. And so cur is a current sum plus equal to nums J. Alright, so we did that, and now we do another thing. So basically, we need to update our result. And the way we do that is result is going to be the maximum between the current result value and the current sum that we're keeping track for over here. Okay, now we need to go to the other condition is what if a nums j is inside of our unique set. So in that case, we're going to go in a while condition. And we're going to stay in this while loop. And we're going to stay in this loop as long as nums j is in the unique set. Okay? So as long as nums j is in the unique set, we go over here. And what are we doing? So first, we're changing the I pointer. And when we change the I pointer, we need to account for the fact that a current number which I was on is not there anymore. And the way we do that is by subtracting that value. So current minus equal to nums, and we're going to remove it from index I. And then another thing we need to do is we need to remove this from the unique set. So the way we do that is we do unique and dot remove, and we want to give it the value we want to remove. We want to remove the value nums I. Perfect. And the last thing we want to do is we need to iterate I by 1. So I plus equal to 1. So at the end of this, we're going to keep going as long as nums j is not in unique. And then at that point, we're going to exit out and do the same steps over here. So by the time j reaches the very ending, we're going to have our results stored in res, and that's what we end up outputting. So hopefully this solution did make sense to you. And thanks a lot for watching, and do let me know if this video helped you. Thank you.